David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Today's lesson, the distance between 2 points. This is an intermediate step in developing the distance formula, which will come in the next lesson. So let's take a look. Here's a typical question that you might get. Find the distance between the point 2,4 and the point 5,1. Okay, so we're going to do this graphically. Okay, so the first step involves plotting my 2 points. So here's my axes scaled up to 5, 1, 2, 3, we're up to 4 on this side. Now we're going to go 2 over and 4 up. That's right there. That's the point 2, 4. Second point is 5 over and 1 up. It's right about there. That's the point 5, 1. And here's the distance we want to find. That's the length. Okay? Now, we're going to use something special about right triangles to calculate that distance. It's a little hard just to read it right off the graph because it's a sloping line, so we can't do that. But what we can do is we can draw a vertical down to there and a horizontal across to there with a right angle in there, and now we have a right triangle. We know some stuff about right triangles, like if I know this length and that length, then I can use this thing called the Pythagorean Theorem to calculate that length. So let's label some points. First off, we're going to need that point. What is that point? That's 2 over and 1 up, so that's the point 2, 1. Okay, we're going to call this one A, we're going to call this one B, and we're going to call that one C. Okay? So now that I have a right triangle, I can write a Pythagorean Theorem equation that's expressing the relationship of this leg, and the hypotenuse. So if you remember, Pythagorean Theorem is generally written like this: a squared plus b squared equals c squared, where c is always the hypotenuse and a and b are the 2 legs. So this would be our c in this case. Here's leg 1 and leg 2. So now let's substitute in these big letters in our Pythagorean Theorem. That's going to be ab squared plus bc squared equals ac squared. Okay? So now we have an equation that we can start plugging in values for and solving. But we need to figure out what the length of AB is and what the length of BC is. Now we can read these right off the graph. To get from here to there, I have to go 1, 2, 3. So AB is 3. And then also to get from B to C, let's count that out. 1, 2, 3. That's also 3. And a quick aside, distance is always positive. Okay, it's never negative. So if we counted from here, 1, 2, 3, it's still 3. Okay, so don't ever use a negative distance. So now that I know AB and BC, I can substitute my 3's in and go 3 squared plus 3 squared equals AC squared. Okay? So now I'm in good shape. I have 2 numbers. I can combine these and get a single number, and then I can find out what AC is. So let's do this. 3 squared is 9, plus 9 equals AC squared. 18 equals AC squared. Now if I want to find out what AC is, I know that this length here squared is 18, but I need to know what AC is. So I'm going to take the square root of both sides. So AC is going to equal the square root of 18. Now I'm not done. If you remember your work with radicals, you've got to look for perfect square factors under the root sign and factor them out. So this is going to be 2 times 9, because 18 is 2 times 9. 9 is a perfect square. It comes out of the radical as a 3, and our answer is 3 root 2. Okay? So in general, on these problems, if you see roots, you want to leave your roots in your answer. You want to simplify your roots. Don't put root 18. You won't get full points for that. You want to simplify that down to 3 times root 2. one for you to try. Very similar to that last problem. Find the distance between the point 1, 2 and the point 3, 7. Now remember, what we did was we plotted the points on the coordinate plane, we drew a right triangle, we figured out the lengths of the legs, and then we solved for the hypotenuse. So go ahead and pause the video, give that a try. Okay, let's plot my points. 1, 2, 1, 2, that's right there. And then we've got 3, 7, so we're going 3 all the way up to 7. So this is 3, 7, and this is the point 1, 2. So we want that distance right there. So what I'm going to do is drop a vertical line all the way down. So this is 3, 7, so we're going to come all the way down to there and go all the way across 2. So we have to figure out what that point is there. That is the point 3, 2. So now I have my right triangle. I need to find my C. I'm just going to label that with a lowercase c, and we'll call this one A, and we'll call that one B. So what's the distance of A? We go from 1 to 3, so it's 1, 2. So A is 2, and B goes all the way from 2 up to 7. So B is 5. So using these two values, I'm going to plug into a squared plus b squared equals c squared. And my a is 2, so that's 2 squared plus 5 squared equals c squared. Working that right along, 2 squared is 4 plus 5 squared is 25, so that's 29 equals c squared. So c equals the square root of 29. And we can't put that into a decimal. That is a prime number, so it's not going to factor down. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.